In this problem, we're told to find the definite integral from 0 to pi over 2 of the cosine squared of theta d theta. So in order to solve this problem, there's some trig identities that you need to know, which are going to be related to the cosine squared of theta and the sine squared of theta. In this case, you're not going to use the sine squared of theta for this problem, but it's just something that you need to know for future ones. So the cosine squared of theta, you can rewrite it as the cosine, or 1 plus the cosine of 2 theta over 2. And then for sine squared of theta, it's 1 minus the cosine. So it's just 1 minus cosine of 2 theta over 2. So the only difference is this minus sign, but we're going to use this one to solve this problem. And so just write these down if you need it, but I'm going to erase it from the screen. And these are really important to know. So just write it down. So if we rewrite our integral, so as we said, or as I said before, the cosine squared of theta, we can rewrite as 1 plus the cosine of 2 theta, and then it was over 2, right? But since it's over 2, we're basically just multiplying by 1/2, but I'm going to move the 1/2 out of the integral. So it's just equal to 1/2 times 1 plus the cosine of 2 theta d theta. And so now we have it like this, we're going to actually be able to just solve the integral right away. So what we can do is just say it's equal to 1/2, right? And so we can take the integral of this, right? So what is the integral of 1? Well, the antiderivative of 1 is just going to be theta, right? So theta plus, and then the cosine of 2 theta. The way you want to think about this is just work backwards. You could use u substitution to solve this, but I think it's much easier just to think about it. So we know the derivative of sine is cosine, right? And so we know it's going to be the sine of 2 theta, right? Because the inside is going to stay the same. But if we do this, it's just going to be 2 times the sine, or 2 times the cosine of 2 theta, right? But we don't have 2 here. We just have 1. So we need a 1/2 on the outside, right? So what you want to do is just think of something that if you take the derivative of it, you'll get this. It just makes it a lot easier to think about, right? And if you test this, cosine of 2 theta, right, times 1/2, but then you multiply by the derivative of the inside. So multiply by 2, 2 times 2, or 2 times 1/2 is just 1. So cosine of 2 theta. So really this is just going to be plus 1/2 times the sine of 2 theta. And so now we've got it like this. What we're going to want to do is go ahead and solve, right? So we've got the integral. And so we're just going to evaluate it from 0 to pi over 2. And then remember, we have to multiply by 1/2 out front. So if we plug in pi over 2, right? What you should notice first is if we plug in 0, it's just going to be 0. Because if we plug in 0 plus, and then 1/2 times the sine, this is going to become 0. It's just 0. So really, it's just 1/2 times pi over 2 plus 1/2 times the sine of 2 times the pi over 2. So 2 times the sine over, it's just going to become 2 pi over 2, right? That's going to cancel. So it's just a sine of pi. And so the sine of pi is just 0, right? So 0 times 1/2 is 0. So it's just 1/2 times pi over 2 plus 0. So it's just 1/2 times the pi over 2. If you go ahead and do that, you're just going to get pi over 4, right? 2 times 2 is 4. So it's going to be equal to the pi over 4. So this right here is going to be your answer. And hopefully you found this useful.